Welcome to EDU World Space.
To find the distance from a point to a line that contains the given points, you have to do a few things. First, let's find the slope of the line. So if this is line L that contains the 2 points, slope is found by the difference of your y coordinates over the difference of your x coordinates. So this could be like 1 minus 4 over 5 minus 2. It's the difference of your y's over the difference of your x's. That's negative 3 over 3 or negative 1. So the slope of the line that contains the point is negative 1. Let me just give you an image here. And then we have some point P at 1, 1. The distance between the point and the line is going to be along the perpendicular. So the perpendicular slope that we really are going to care about is positive 1. You may have learned of opposite reciprocals, or the product of the slopes have to be negative 1, and which would make the perpendicular a slope of 1. We want to write an equation. Actually, no, we don't. We want to find the distance. So we need to think of the line that is going to, what this line would actually be. So that's step 2. Think of y equals mx plus b. We have to go through the point 1, 1, that's a y coordinate of 1, and an x coordinate of 1 with a slope of 1. Because we need the perpendicular slope. 1 times 1 is 1. Subtract 1 to both sides, and b is 0, meaning y equals 1x, or just x plus 0, is the equation of the line. Step 3 would be, where does the line y equals x and the line that contains these points, when are they the same? Well, we haven't found that yet. So the slope of the original line L is negative 1. And so if we use one of the points, like 2, 4, where the y coordinate is 4, the slope is negative 1, and the x coordinate is 2, that's 4 equals negative 2 plus b, or b equals 6. So that would be y equals negative x, or negative 1x plus 6, the equation of line L, the equation of the perpendicular. We need to find, where do they meet? So we set them equal to each other. Negative x plus 6 equals x. That is really what step 3 is. So 6 would equal 2x, and x would equal 3 when you divide 2 to both sides. So if x equals 3, then y equals 3, which means this location would be at 3, 3. So this is now a bad picture. I'm not actually on the coordinate plane. If I would see that this was actually up here, right? And if you were graphing this yourself, you might have noticed this. But they're going to intersect at 3, 3. Now, the question is, find the distance. So we have the point 3, 3, the intersection. And the original point P at 1, 1. So we need to find the distance, and this is the last step. The distance between 3, 3, the intersection, and 1, 1 point P. Let's use the distance formula. That's the square root of the difference of your x coordinates squared plus the difference of your y coordinates squared. Our x coordinates are 3 and 1, and our y coordinates are 3 and 1. 3 minus 1 is 2 squared is 4 again, so we get the square root of 8. This is an exact answer if you have to find or write your answer exactly, or since 8 is 4 times 2, you can square root the 4. This is the same thing as 2 times the square root of 2. Or if you're rounding, this is about 2.83. All of these depending on how you have to give your answer.